Hello and welcome to this new video from Preach. In this video we're going to present how to configure high availability with the Cloud Security Connector for Zscaler with PriCPA and Advanced Net Gateway. One of the core features of the connector is that it provides a very high availability, provides several tools for high availability. First is Zscaler node redundancy, is automatic failover. When the Zscaler primary goes down, it goes to the secondary, and if the primary goes back, it can return to the primary, or you can keep the communication with the secondary. This is automatic failover and recovery for the nodes. But also on AWS, we can provide high availability, and you can deploy two connectors on different availability zones. In case AWS zone goes down, you can the other connector the connector in the other availability zone that is active will automatically take control of the communications. Then the connector provides high availability for Zscaler nodes and also for regions on AWS. And let's take a look how to configure. On the previous videos, we were doing it with a single connector, the configuration to Zscaler, and also we did the configuration for bypasses, and finally we did the configuration for PriCPA. There's the three exits. At this moment we have this connector running with the three main services, that is traffic to Zscaler, bypass traffic, and internal connectivity of this region to other regions on our network. And we have also here for lab purposes Bastion host to connect to the internal instances, but the truth is now, because we have PriCPA enabled, we can go direct. But anyway, this is still there. What we are going to transform now is to add a second connector on different availability zone on AWS. And the way that the high availability works is the following. In our case, connector A is active, and we have a route that all traffic goes via the ENI of this connector. This is what is running today. We will add a second one, and we will configure high availability between both. And connector B, what we'll do is to test via the VIP proxy connectivity to Zscaler in order to validate that the connector A is active. Meanwhile, the connector A is active, B will do nothing, is passive. But when the connector A goes down, connector B will detect, okay, we don't have more connectivity to Zscaler via A, then the connector A is offline. Then the B, using the AWS CLI, will touch the route. You can configure multiple routes. I have one route, but you can have multiple route tables and routes, and will change in this route 000 the destination from ENI A to ENI BBB, and all traffic will flow now via this connector B. There is a particular case when there is PriCPA active. This happens when the PriCPA is active, that the connector B also will get the PriCPA IP that was assigned to this system, and will move the PriCPA IP to the B. The reason of this is because the PriCPA needs a static IP per site. Then I need to move the IP here in order to work with PriCPA. This is why we do this, because this avoids you to put load balancers or to put something smart in front of the connectors. Then with the connector will do all job for you. Then let's put the connector in place, and this is our task. We need to create first a new connector on different availability zone. Remember, I'm using Terraform, but you can do this using CloudFormation. To get access to the Terraform templates, go to our main page, medicbridge.com, documentation and support, Cloud Connector for Zscaler. Click here, you will land on this where you can select Amazon. Click here, and we end on the documentation. The administration guide, the videos, this video will be here, and the files in use and the templates, how to create the connector and other templates that we need for the installation. Let's take a review of the parameterization. I will go here to my template. This is connector A. I will go to connector B. Remember, the template provides main, output, Terraform autoboards, and variables. And these files these defaults you can use to, with these defaults, you can do the initial deployment or upgrade the CSE when copy the content of this file to the config user data. What I did is to copy the default on config user data, and I will pass some values during the configuration. For example, the registration of the CCM agent, the syslog, the outbound firewall configuration. The PriCPA, I don't want to create new PriCPA connection, because I need to pass the PriCPA configuration from A to B, because both has exactly the same values, and that's much it for the moment. On the Terraform autobars, remember, you need to put the values of VPC, external subnet, and internal subnet. During the previous videos, we did this, and I have the value of the VPC here. We did this using Terraform, and I have my external pair and my internal pair. Number 2, then I'm going to install in number 2 the new connector. What else? A number for the connector is Ohio B. Instance name the same. Stack name is instance, region, key name, and the profile. This is the role that is needed for the connector. Well, everything looks fine. What I will do now is Terraform plan to validate this. And Terraform apply to create it. Yes. The Terraform now is creating the elastic IPs, the security groups, the network interfaces, doing all attachments, and the instance, and everything is fine. Now I have this 2 public IP, and this is the connector private IP. Then I will use this IP to get access to the connector via the Bastion host. And I have here number B edit. I need to put the IP. I might be using Bastion host as a sham host. Okay. Probably I need to wait a little bit to wake up, but let's try now. Too early. Okay, let's wait up to the instance is up and running. Refresh my console, and it's initializing. Okay, number B is initializing. Well, meanwhile, we can have a conversation about the instance type. If you would recommend to use the tier 3 medium or large, mainly because not because the connector it consumes a lot of resources. In AWS in particular, the AWS discriminates the bandwidth per instance type. Then sometimes you have an instance on tier 3 small, and you are consuming 5% of the CPU, but the bandwidth is not the best. And this is because AWS is controlling the bandwidth on the instance by instance type. Yeah, it is what it is, and we need to survive with them. For that reason, maybe you need to put in medium, and you're consuming almost nothing CPU, but the performance is better because AWS is getting you better performance. Okay, now looks it is active, and let's try again to connect to the host name. Let's duplicate this communication. Okay, and he is telling me now the tunnel was never configured, and this is my tunnel source IP. And the task now is extremely simple. Zscaler 3. I will create a static IP, and I will associate to the location. That is on my step 2, create a static IP, GRE tunnel, and add it to the location of the other CSC. Good. Let's go here, administration, static IPs, add static IP. This is the IP, and as description I will put that is Ohio. Up, Ohio P. Next, save. The next I will do a GRE tunnel, selecting the IP, put the command, next, and select the range, internal range, next, and save. Okay, now let's go to location management. I need to find my Ohio location. I guess it's something like that. Here it is. And I will add the new IP 79. Done. And one important point here, I need to pick up these 3 values: primary destination, secondary destination, and first IP of the internal range. Okay, then let's put this in a notepad, because this is the information I need to configure on the connector. Then save and activate. Now we can go back to the connector and copy the values. Are you ready to continue? Yes. 1. Your cloud is my cloud is Zscaler 3. My values are primary destination IP. Second destination IP. And finally, first IP of the range. With these 3 values, is all you need to do in the connector, and return to primary true. And yes, and this is the first installation. The connector will reboot and will create the rules and all the stuff for connecting to Zscaler using GRE. And as soon it ends, we need to do the next step of on our presentation. Next step is running the initial configuration wizard for high availability. And on this wizard, we are going to tell the connector to manage this route. Currently, this ENI is the ENI of the CSC active of this one. Okay. Then we will configure high availability here, and we will copy high availability in the other connector. And then let's move on, and let's run on the connector A. When I'm here, I will run high availability. Then go number 16. Here is explanation how to do it, the roles, all you need to do. But let's go straight. What do you want to do? I will configure high availability in manual configuration, which is route table ID. I need to come to my route table, details, route table ID. Now it's checking the value and destination. I want to control this destination. Then I'm going to take control of this route destination. Do you want another? No. Okay. Instance ID of the other CSC on the pair. Let's see if it is active now. Okay. Here is the B. I will copy the instance ID of the other node. Okay. And SNS message topic. The connector sends an SNS message after something happens with high availability. It's notifying the change on high availability. We created this SNS message by Terraform in a previous video. I didn't remember this template. It is in our site, and you can use it. Paste. Do you want to apply changes? Yes. Okay. Now I need to copy this on the other connector. Okay. This is this value. And if let me copy this. Copy. Let's put here. If I check here the high availability status, it will show me now that the service is active, it's running 35 seconds ago, the role in use, the route. This is the most important here. The routes using this target. This is the ENI active for the routes, and it's the CSC, this CSC. Okay, and here shows the configuration of the CSC. And that's it for the moment. Then let's configure next step on the demonstration. Configuration high availability in the first CSC, copy the high availability in the second CSC. Then let's go to Ohio now. On high availability, enable JSON and copy the JSON file. Copy. Ohio B. Paste. It's validating via API that everything is fine and it's active. Okay, then you can check now on the DNS. And high availability is telling you that the route is using the other CSC on the pair. Okay, then on my network diagram, this route is via this ENI. Good. Next step is copy advanced NAT gateway and PriCPA configuration. Well, we did the advanced NAT gateway via the config user data at the beginning. Then we can check it, but we need to configure the PriCPA configuration from A to B. Then let's check first. Let's do in both cases. Let's copy the configuration in both cases. Then advanced NAT gateway. Let me check this. I put no probably on the command. I made a mistake on my file. This is the reason. Phone firewall. Okay. Phone firewall was not configured because the connector was not able to reach this destination, and because this destination is restricted by IP, then I need to enable the IP here on my bucket. Then I need to come to the B and see what is the tunnel IP of B. That is this one. This one is the IP we use to reach the destinations. Then I need to go to my S3 bucket. Okay, let me go to my S3 bucket, and the S3 bucket here I need to go to Terraform Autobars, and I need to add this IP, and I will put here Ohio A and B. Save. Okay, and now let's apply the Terraform plan. We'll add this IP and Terraform apply. Okay, yes. Okay, then I need to pick up this URL and to configure on B. Okay, then let me go to configure outbound firewall rules. The advanced NAT gateway is not configure. Base. I want to configure. Do you want to refresh? No changes made. This is one still. I'm going too fast, maybe. This is when this is blocked by permissions. Let's try again. Let's try again. Okay, now it's working. Too fast. And apply the rules. Perfect. My next step is to pass, according to this, copy advanced NAT gateway and PriCPA configuration. I'm going to copy the PriCPA configuration. And here, what I need to go is 17 and show local configuration number 4. And this information is the information I need to copy to the other connector, the token and the JSON file. First, remember PriCPA is 2 steps, local configuration 1, and then the URL. And here I will use token and JSON. Do you want to continue? Paste the token and paste the okay, and first step and second step, 1 to load the peers JSON file, and I will set up the URL for the peers JSON file that I can get from my bucket. This is my peers URL. Copy. Okay, and B. Paste. Do you want to refresh? Yes. Let's see, compact. Yes. Now it's doing the PriCPA configuration on this node. That is the same that the A. They have exactly the same configuration, but here the script need to do the security groups for all IPs on my network. Then everything is updated now. If I take a look of high availability, I have private access configured. Outbound firewall is configured. This is configured, and this is also okay. The last step is to configure the remote management networks that I didn't put here, but I have remember in PriCPA, when you want to get access to this connector from another place to the internal interface, you need to configure this remote network as remote management network. Okay, but let me put this clean. Then 19 management networks. 192. I have 3 management network. And the last one is 10.63.1.24. No, and apply. Okay. Good. Let's take a look now. Show configuration status on the B. I have my 3 management networks. High availability is via the A, and everything looks good here. And if I do show configuration status here, okay, then it's a lie. PriCPA, management networks, outbound firewall, DCSE. Okay, let's do a test from this is a server on Azure. One of the tests that from a server on Azure, we have a rule here that I can ping this but not this. This is done by private apps, because it's zero trust, but I can SSH this one. Okay, then let's test the ping first. This is from Azure. It works okay, and the other ping should not work. That is this one, because zero trust rules doesn't allow to do it, but I can telnet this from here. Okay, good. Then PriCPA is working fine now. It's working as expected. Also, I will do a quick test here on this Bastion host that is from the back, because we can ping. Let me show this on this. We can from this Bastion host we are running here, and we are going to bypass this. What I'm going to do is to start in a script that tests when the ping stops and start when the CSC moves when the route is moved from one to the other, to see how long it takes. Then I will start this script here, and we're going to ping this ip.maidenheadbridge.com. Okay, ping started. Now, next step, to test high availability, let's go to the EC2 instance here, and let's stop the active, that is the A, and the route, this route table should change to the, let's go to this instance actions, stop. It takes some time to stop. You say stopping, but takes some time. Then right now we need to wait a little bit for the instance to be stopped. Nothing to do meanwhile. Mhm. Well, meanwhile, we can see the logs. The CSE generate logs to a syslog. This is a syslog in the cloud they have, and it's telling me, well, this is the last action we did to add the management network. But here I was showing all the change we were made to this connector and all the PriCPA configuration and blah 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 blah. Also, you can have um, logs per traffic that we will create video about visibility on the connector. Let's back to the instance now. Okay, now it's stopped. It's not working anymore. Then what we expect is the B to take control and to move the route via the other connector. And if I refresh here, I need to select the route table. Okay, now the ENI is the ENI of the instance B. If I go to networking here, the ENI is the internal one. This one, MB, yeah. This should be the 7A. 7, okay, or 8A. Okay. Well, let's do the test again. First, let's take a look what happened with this pin, permanent pin that was stopped at 5017 and started at 5180. In general, it takes about 90 seconds, 60 seconds, but this is a region, right? This is when the region goes down. Then this is because the API, but it's less than a minute that the routes and the detection and everything start working again via high availability. Then now the traffic is flowing via connector B, and I show now all traffic is via this connector B, high availability. And in the case of PriCPA, if I do the test here, I should telnet this is working, and I should ping. No, this is the restricted pin. The enable is 151. Then PriCPA is working. If I check now the connector B, this one, we will see two things here. First, the bypass IP is attached to this connector. That is what we want. And second, that the gateway for the route was changed to this 78 DCSE. Okay. Well, this is the end of the demonstration. As you can see, the connector is very smart, reliable, very stable. How it works with high availability, and it's simple to configure. It's just to create on the first the configuration and to pass to the second. It's like a copy paste, and the connector take care of the rest. It's doing everything for yourself. And then this is then. Thank you very much for your time. If you have any questions, please, you can contact me directly or contact our sales team or check our website or our support site if you need to open a ticket. Thank you very much and have a good day. Bye.